Hi class, I wanted to go over a video about simplifying radicals or square roots. So a lot of times we call square roots radicals. So if you hear that word, it just means square root. So I want to talk about kind of like our perfect square roots first. So our perfect square roots are always those numbers that are multiplied to themselves. And so for example, like if I have the square root of 49, right? Well, 49 is broken down to 7 times 7. And so since this is one that has the same number multiplied, when I do the square root of 49 and solve that, then my answer is just 7. And it's because it's like saying the square root of 7 squared. So you agree that 7 times 7 is 49. But anytime you take a square root, so write the square root of a squared number, those cancel out and you're left with whatever's inside. And so that's where this comes from is when I have the same number twice and I square it and then I take the square root of it, it cancels it out. So I can do that again like, well, let's say like 36 because 36 is 6 times 6. So like I could rewrite this as 6 squared because 6 times 6 is 36. So this is the same thing. But again, the square root and the squared are opposite of each other. So they cancel each other out. And so you're left with just 6. And so these are examples of those perfect square roots, right? So the perfect square roots are anytime you have a number times itself, right? Except for 1, of course. But like 2 times 2 is 4. So the square root of 4 is going to be one of those perfect ones, right? 3 times 3 is 9. So 9 is going to be a perfect one. So the square root of 4 is 2. This one is 3. 4 times 4 is 16. 5 times 5 is 25. And so we could keep going, right? So anytime you have a number times itself, it's when we get our perfect ones. Today, we're not really worried about the perfect ones. We're worried about what happens when I don't have a perfect one and we don't want a decimal. We want to do something that's called simplifying. And so I'm going to show you kind of an easier one first, and then we'll get some harder ones. But my example that I want to start with is the square root of 20. So the square root of 20 is not perfect. There are no two numbers that are the same that are going to give me 20. But what you want to do when you're simplifying these is you want to think of a factor tree, right? So we're factoring these. But one of their factors, one of them, not both, just one of them, has to be one of those perfect ones that we just talked about. So remember the perfect ones are 2 times 2, which is square root of 4, 3 times 3, which is 9, and then 4 times 4 is 16, 25, 36, 49. I can keep going. Yeah, 7 times 7, 8 times 8, 9 times 9, 10 times 10, so forth. 11 times 11, 12 times 12, okay? But right now I'm looking at square root of 20. So I want to look at this list, and I want to grab the biggest off the list that goes into 20 evenly. And so out of this list, 4 works, right? I could say the square root of 4. So the question is, what is 20 divided by 4? Well, it's 5, the square root of 5. And so I look at both of these, and I want to make sure that I can't refactor any of them with this list that we have, right? And so I can't. And so then we can solve. Well, we know the square root of 4. The square root of 4 is 2 squared and then the square root of that. And remember, when we take a square root of a squared, it goes away and we're left with just 2. So this, we're actually left with just 2. It's one of those nice ones. Square root of 5, I can't simplify. And so that one just gets carried down. And so my final answer is 2 square root of 5. And this is how you simplify a radical, okay? We didn't get a decimal. We took a square root that wasn't perfect, and we pulled one of the perfect ones out of it, okay? And we simplified it. So let's try one that's a little bit harder, okay? Let's try 9 times the square root of 45. So you're going to want to ignore that 9 for a minute, and you want to just focus on the square root of 45. And so again, you want to find factors of 45 that one of them is those perfect square. So we again have the square root of 4, we have the square root of 9, square root of 16, and we can keep going. But I know that 9 goes into 45 evenly, right? And so I can say the square root of 9 times the square root of 5, because 9 times 5 is the 45, okay? I leave them in the square roots until I have a perfect one. So when I have a perfect one, like the square root of 9, the square root of 9, remember, is 3 squared. And then when I take the square root of that, the squared and the square root cancel, and so I'm left with just 3. The square root of 5, I can't do anything with that. I just have the square root of 5. Now, normally, if it was just the square root of 45, I would be done. The answer would be 3 root 5. But there was this 9 out here. That 9 is now on the outside with this 3. And so I need to multiply those together because they're both on the outside. So 9 times 3 is 27. And then I still have that square root of 5. So this is my final answer, is 27 root 5. And we're going to be practicing these a little bit more, but I really need you guys to understand that this is simplifying radicals, and these will be on the tests where we don't want a decimal anymore. We want you to actually just simplify it this way, okay?